Okay, so welcome to integrating rational functions. And in order to do this, we're going to have to use the natural log. So our objectives are to use the natural log rule for integration to integrate a rational function, and then to integrate some trig functions. Okay, so if we're given this problem, we have to find the indefinite integral. And by first guess, we want to try to use a u substitution. Maybe if I can get this to turn on, we'll use a u substitution. So if I were to use a u substitution, what should I make u equal to? Not that. Okay, so if I let u equal to 3x plus 2, then remember we have to make sure that du is in our problem, and du would equal to 3 dx. Well, I have dx, I don't have 3 dx, but I can divide through by 3 and get 1/3 du is equal to dx. So rewriting my integral, I get 1/3, because I'm pulling out the 1/3. I'm replacing dx with 1/3 du over u. Well, hopefully when you see that, you recognize that du over u is simply the natural log of u. So this would be 1/3 the natural log of u plus c, which of course we can write as 1/3 the natural log of 3x plus 2. Now you may be asking, why am I putting absolute value symbols around this? Well, we have to remember that the domain of natural log is from 0 to infinity. So in order for me to take in order for me to evaluate this, I have to remember that u has to be greater than 0. Okay, this one is similar to that. One of the things I can notice that if I were to distribute this, I get x squared plus 2x. It's a rational function. Also, I want to look to make sure that the exponent on the bottom is bigger than the exponent on the top. If that's not the case, then I have to use long division. But in this case, the exponent on the bottom is bigger than the exponent on the top, so now I'm going to try to use a u substitution. I'm going to make u equal to x cubed plus 3x squared minus 4. Well, of course, if I do that, then du would equal to 3x squared plus 6x dx. Now, at first glance, that may not seem as if it's in my problem, but I can factor this out. I can factor out 3 and get x squared plus 2x dx. Now, that certainly looks similar to what I have. Once again, I have to divide by 3 just to get this times dx by itself. So I get 1/3 du is equal to x squared plus 2x dx. And since this is in my original problem, I can replace this with 1/3 du. So rewriting this, I now get 1/3 du over u. And again, du over u becomes the natural log of u, so I can write this as, let me get this out of the way, 1/3 the natural log of u plus c, which is of course 1/3 the natural log of, what was u? X cubed plus 3x squared minus 4 plus c. Now, this one presents a little bit of a challenge because, as I said before, in order to use rational integration, the exponent on the bottom has to be bigger than the exponent on the top. If the exponent on the top is the same as or bigger than the exponent on the bottom, I cannot use the methods I was using before, and I have to use long division or synthetic division. So I'm going to just use long division here, and I'm going to divide x plus 5 into x cubed. Remember, if a term is missing, I have to replace it. And if you don't recall this, you may want to watch a video on long division or synthetic division. I would go, if you don't remember it, I would do long division, because synthetic division won't work in every case. Okay, so we want to do x. What times x will give me x cubed is x squared. So I divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So x goes into negative 5x squared, or negative 5x times. So I repeat. So divide, I just divide it, and then I multiply. So that gives me negative 5x squared plus 25x. Divide, multiply, subtract. So when I'm subtracting, I'm just changing the signs here. And that gives me negative 31. Is that right? That gave me negative 25. And so I changed that to positive, so that should be 19. Sorry. That didn't look right. So that gives me 19x, right? Because that's negative. I brought that down, it was negative. Negative times a negative is negative. Then I changed it to positive, so that'll give me 19x. And give me a 19 here. Bring down. And that will give me 19x plus 95. Subtract, so that gives me negative 115, a remainder of a negative 115, which we write as negative 115 over x plus 5. So now what I'm integrating is x squared minus 5x plus 19 minus 115 over x plus 5. Okay, so I'm going to integrate each term separately. So this one integrates to 1/3 x cubed. This integrates to 5/2 x squared plus 19x. Now for this one, I'm actually doing a u substitution in my head. I'm letting u equal to x plus 5, du equals to dx. So then this just becomes negative 115, the natural log of u, but u is x plus 5. So I kind of, when they're simple like this, I can kind of just do them in my head, plus c. Okay? Okay, so once again, I'm integrating this. I can't use any algebra to simplify it, so I have to ask myself, what should I make u equal to? So, well, one thing I can do is I can rewrite this, because I'm not seeing anything that I can make u equal to that makes sense. So, but I can rewrite this. So I can make this 1 over x. Rewriting this would be 3 times the natural log of x squared. I'm sorry, of x. Which, of course, I can rewrite. I'm just going to rewrite it there to save space. I can rewrite this as 3x natural log of x. Just bringing that 3 into the front. Okay? Now, what should I make u equal to? Well, I can make u equal to the natural log of x. So then du would equal to 1 over x dx. And I have 1 over x dx. I have that in my original problem. I can factor out that 1/3, or bring out the 1/3, and now I have the 1 over x dx is du, and the natural log of x is u. So it's going to give me something funny, but it makes sense. It's 1/3 the natural log of u, which would be 1/3 the natural log of the natural log of x. Beautiful. What did I forget? There you go, plus c. Okay, so we're evaluating this definite integral from 0 to 1. And so we're basically, it's the same thing, except for at the end we're going to evaluate. So what I want to do is, because the exponent at the top is the same as the exponent on the bottom, you have to be careful with that, I'm going to have to do some long division. So I'll do x plus 1 divided into x minus 1. Well, x goes into itself one time, so I divide, now I multiply, then I subtract, making both of those negative, so I get negative 2. And there's not anything that I can bring down, so this becomes the integral from 0 to 1 of 1 minus 2 over x plus 1. So integrating this, the integral of 1 is x. The integral of 2 over x plus 1 would be minus 2, the natural log of x plus 1. And all of this I would integrate from 0, I would evaluate from 0 to 1. So that's going to give me 1 minus 2 natural log of 2 minus 0, and then the natural log of 1, which is 0. So that's 0 minus 0. So this is my answer. So one of the things I do want you to see is that this answer could also be written as 1 minus the natural log of 4. And College Board likes to do stuff like that just to throw you off your game. And the reason I can do this is 4 because the 2 becomes the exponent, and 2 squared is 4. Okay, this is basically just using the fundamental theorem of calculus. So if I take the derivative of this, remember using the fundamental theorem of calculus, this simply becomes 1 over x squared, but I have to take the derivative of x squared, which is 2x. Simplifying this, I just get 2 over x. And because it's the FTC, the second fundamental theorem, there's no C required, because it's technically it's a, what do you call this? I can't think of it. It has bounds. Can't think of what that's called right now. Okay? Finding the area is simply finding, we're just integrating across this region. So to find the area in the curve is just integration. We do a lot of this in Chapter 6, but this is just an introduction to it. So I'm going to integrate the integral of x plus 4 over x, and I'm integrating that from 1 to 4. Because those are my bounds. Now, I can simplify this and write this as 1 over 4, 1 plus 4 over x dx. So now integrating that, that gives me x plus 4 natural log of x, and I'm evaluating that from 1 to 4. So that gives me 4 plus 4 natural log of 4 minus 1 plus 4 natural log of 1. As I said before, 4 natural log of 1 is 0. So that gives me 1, that should be parentheses around there, be careful with your parentheses. So 4 minus 1 is 3 plus 4 natural log of 4. And of course we could write that as 3 plus the natural log of 4 to the 4th, which I think is 256, but don't quote me on that, so I'll just write it that way. Okay? All righty, finding the average value. So remember the formula for average value is 1 over b minus a times the integral from a to b of f of x. So this would be 1 over 1/2 times the integral from 0 to 2 of secant pi x over 6. And I think secant, the integral of secant x is one of those weird ones that we don't know. But I do have to remember to use chain rule, so I have to let u equal to pi x over 6. So du is equal to pi over 6 dx. So dx is equal to 6 over pi du. So 6 over pi would come out, so I'd have 6 over 2 pi times the integral from 0 to 2 of secant u du. Like I said, I think that's one of those weird ones, so if I go back to the very beginning of my slides, I hope this isn't giving you whiplash. I think I have that written down, yes. So the integral of secant u du is the natural log of secant ux plus tan u. Sorry. I don't know what that's doing, but hopefully it'll stop by the time I get to where I'm going. So, create, no, I don't want to do that. I don't know what that's doing. No. Okay, so what we have then is 6 over 2 pi times the natural log of, and you know I forgot what it said already, so I think it was, oh, I did something wrong. What did I do wrong? I forgot to change my u's. These are u's, but I kept these as x values, so I'm bad girl. So u of 0 is going to be 0, but u of 2 is going to be pi over 3. So bad Melissa, bad Miss Boulder. I forgot to change my limits here. It should be pi over 3. I hope you caught that. So I think it was secant u, was it plus tan u or something? I don't remember. But whatever it is, you can figure that out from there and just evaluate it. And I would evaluate that from 0 to pi over 3. Okie dokie? All right, I think that's it. And that's your homework assignment. So that is lesson 2. Have a great day.